So one of the areas that are not necessarily well understood are mechanical seals, and particularly debris wells in particular. Debris wells are designed to catch any particulate that's generated from the rotating face rubbing against the stationary face, and it generates particles. And you can see that if this little barrier weren't there, it could fall down into your process. And so the thought is you put this debris well in and it catches any of that debris and it keeps the particulate out of your process. If you have a downstream process, particularly a sterile process, something that cannot be filtered to get the particulate out, it can be a good idea to have these. So in terms of the rules about crevices and non-draining and being easy to clean and easy to sterilize, these things are about as non-sanitary as you can get. Because this whole thing right there is a gigantic crevice. This by design is capturing and non-draining. Now what they typically do is make a low point drain coming out here, often threaded, but if you catch them they'll put in a triclover for you. But a lot of people will install these things and then just valve it off or plug it and never actually do anything with that. And so they've installed this in their process and they're not cleaning it and they're not sterilizing it. And during SIP in particular, particularly if you're doing an air purge as opposed to a vacuum cycle, you will not get the air out of there. This will not get sterile. And I have yet to find a validation person who's been willing to try to validate that. So if you're going to use a debris well in a sanitary process, and really if it's not a sanitary process, why do you need it in the first place? One of the things you really should do is you should CIP in it and overflow into the tank to clean the debris well periodically. And you need to put steam traps on the outlet of the debris wells so that during SIP you're actually going to trap, and that'll get the steam to flow up there and you'll have a drain for your condensate. That's how you do it right. Actually, we're in Factory 7. We had sterile tanks. We were post the final sterile filtration, and we were doing a crystallization and precipitation and drying and all that. That equipment all had debris wells on it, and it was appropriate for it to, because we didn't want any of that particulate in our final powder, which we were generating. But in that case, we did go in and CIP in them during CIPs to flush them out, and then we had traps. Actually, in those cases, I think we usually had 2 traps on opposite sides to make sure that we are getting proper steam penetration and drainage of the condensate. So if you're going to have a debris well, it is important that you are cleaning it and sterilizing it, and it does add to the complexity of the design and the operation. If you have an upstream process that will be filtered later on, I would say don't do it. Just, if you don't need it, don't do it. By the way, this is a Flowserve VRA single seal. I didn't pick it. I have used that seal successfully at both Amgen and at Merck. It's a pretty good single seal. I'm not picking on it, good or bad, but it was a really good illustration of what a debris well was, and that's why I picked this drawing. Just got it offline from their product literature. So debris wells, beware. If you don't need one, if you're going to be filtering downstream, I'd say don't use it. If you do need it, that's fine. Just be aware that you really need to clean it and sterilize it. The one company I worked before I got there had a cell culture process where for some reason, I don't know if it was a Flowserve seal or whatever, but they decided that on their bioreactors, they were going to replace their double mechanical seal that had steam going to it like a traditional bioreactor seal, and replace it with a single seal, with the idea that if they kept the vessel pressurized all the time, it wouldn't matter. And that may be true. I've never seen anyone actually attempt that before. But apparently the guy doing the project wasn't that familiar with mechanical seals, At the last minute, the seal vendor said, "Would you like the sanitary version of that seal?" Of course he wanted the sanitary version of the seal. And what he meant by sanitary was it had a debris well. So they put a single seal with a debris well on a bioreactors, did not steam through it, didn't steam it to trap, and they started getting Bacillus cereus contaminations one right after another. And at first they didn't understand what was going on, and they were looking at everything. They finally said, you know, this started when we replaced the seals, let's put the old one back in. They put the old one back in, the problem went away. So that highlights the fact that this is very dangerous in anything that requires sterility. And I mean, that was just a breeding ground. So beware. They have their place, but they take extra work. You have to use them right, or they shouldn't be in your process because they're not sanitary unless you're draining them. Okay. Double seals versus single seals, they both have their place. One of the big, a controversial subject is for like Wi-Fi pumps, whether you should have a single seal or a double seal. I know that like Fristam typically puts a double seal on theirs, and they have a purge coming off the seal going up into the middle chamber between the two faces. I really don't like, the good thing about a design like that is that it keeps the faces wet. The bad thing about a design like that is if the inner seal ever fails, you are flushing water from the dirty side across that broken face and flushing debris right into your process. I personally, when it comes to Wi-Fi, think a single seal is better. I'd rather have leakage out and know I have a seal problem than force stuff in. It also saves water. And it's cheaper and easier to install. To me, it's a win-win all the way around. For bioreactors and other sterile vessels, I think it's appropriate to have a double mechanical seal. But if you're going to do a double mechanical seal, you probably should sterilize the boundary. Now, with a bioreactor, we typically put steam in there, and then you put a condensing system in there so that you're running on clean steam condensate. For other sterile vessels, agitators, typically where you wouldn't want to get any of that liquid possibly leaking into your batch, you should still make it so you can steam it, but then afterwards you probably want to put sterile filtered air or possibly sterile filtered nitrogen into that cavity to keep it positively pressured. Typically with a double mechanical seal, you want positive pressure in between the faces. However, on even a sterile vessel, if you're keeping the vessel under positive pressure, you can probably get away with a single mechanical seal because any leakage should be out. And so that is actually my preference on most sterile vessels, is to keep it simple and just have a single mechanical seal, but keep your tank under positive pressure all the time so any leakage will be out. If you have a double mechanical seal, and you put a positive barrier in there, if it leaks, it's leaking into your process. So again, so I think we have covered what I wanted to talk about with seals. Any questions on seals? Steam traps, not a very glamorous topic. There are about 3 different types of steam traps. There's thermodynamic, which use a disc, and it's using the property of gas flows faster than liquid and creates a little vacuum. Typically, they are used on drip legs and things like that. They are not good at passing air. So air will act like steam. It will cause the disc to fail, but because it will never condense, it won't open back up. Those are the trap that if you bang them, sometimes they'll start working again. That's only the disc traps. It's not the thermostatic traps that we should be using. You bang on that, you just damage your trap. So please don't do it. And then there's the float traps, which really don't get used in our industry much, but they're used for utilities and things like that. So for our purposes, thermostatic is best. It works on the basis of temperature. And one of the beauties of the thermostatic trap is that it passes air. It will pass air in addition to condensate, so it won't get airbound and it will help get the air out of your system. So the principle of a thermostatic trap is you have a fluid in here. Typically it's got some kind of alcohol in it, and it's actually designed so that when you are nearing the saturation temperature of your steam, that the bellows, that the liquid will start vaporizing inside the bellows will expand and it'll close off and seal the hole. So you have your steam and condensate coming down here surrounding this bellows. If it's cold, the gas in here will all condense, and the bellows will contract, lift up, and open your hole so that you flow condensate out. As the condensate flows out and starts getting replaced by steam, this then heats up and closes off and shuts the hole. In reality, depending on what your steam load is, what you'll often have with a system like this is you'll kind of get it into a steady state where it's throttled partway open, maintaining a constant temperature of condensate in here. And that's fine. So one of the things you should know about steam traps, though, is they were originally designed to conserve steam. They were put on all kinds of steam heating systems, and people didn't want to waste steam because that's wasting energy. So they were designed with a lot of subcooling to prevent wasting steam. Subcooling is the temperature, the amount of how much below saturation temperature it has to get before it opens up. A lot of older traps, and a lot of traps actually in the market now might have like 20 degrees Fahrenheit of subcooling, so around 10 degrees C. That's actually a fair amount of subcooling, and the higher the subcooling, the more likely you are to back up condensate up your pipe and cause you trouble. So typically you want lower subcooling. My personal opinion is when it comes to SIP and sterility assurance, I don't care about wasting some steam. So I want this subcooling as low as possible so that it backs up condensate as little as possible. The other thing is capacity. Depending on the size of the bellows, the size of the hole, traps are rated for how much water they can pass. Typically that's going to be rated in like pounds of condensate or pounds of steam per hour or something like that. You can kind of convert that to a flow rate. I typically want traps that have a higher capacity. Sometimes a low capacity trap on a very small line that doesn't get a lot of load is fine. But if this trap is, say, on the outlet of a tank, and you have all the condensation coming from the tank going through this trap, you're going to want a really high capacity trap. So you want to look at the capacity of the trap. Some of the other things you can get is some traps have different fill fluids for higher and lower subcooling. So again, I would try to get the fill that would give us the lowest amount of subcooling. Sometimes you can get an orifice in there, which will basically bypass the trap so that you always have a certain amount of flow, particularly good in low situations. So along those lines, some people sometimes talk about using orifices, restriction orifices, instead of traps. It can be done. I am not particularly a fan of that because the difficulty with the restriction orifice is it's one size, it stays one size, it's always open. So the good news is it's always open, it's always going to be flowing. But at the beginning of your SIP, when you're forming a lot of condensate, it's not flowing any faster than later on, so you're going to be backing up a lot of condensate. And then later on, when you're done condensing and things are more or less steady state and you're forming very little condensate, now you might just be blowing a lot of steam. So I prefer steam traps because they're designed to throttle open and close based on demand. So I like that function. My favorite traps, though, actually have an orifice built into them. You can either get like a BTM7 with a notch where they basically put a notch right there so that it always leaks through the notch a little bit. Or this is a Nicholson trap The nice thing about this Nicholson trap is it's nice and smooth and shiny on the outside. It's beautiful from a cleanliness standpoint for your clean room. I think Nicholson actually has a trap that I like better. I think it's a CD203, and it has something called an SLR orifice, where it actually has a hole that goes through the nozzle tip and provides an orifice for you. And that's an option. You can get it with or without the orifice, but I like to get it with it because it gives you the best of both worlds. So that you always have a certain amount of flow. So even when you're in low demand situations, you're keeping it flowing. And works, and they're pretty high capacity traps. And they come in different capacities. I think the CD series has 3 different capacities. Again, I talked earlier about a spec break where this does not have to meet all your other piping specs because you're attaching it to a drain system. This isn't touching your product. So it does not necessarily have to be as quite a high a grade material, although typically that's the way they're made these days. One of the funny things in my experience is some of the really old traps that we used to use about 20 years ago that were just brass radiator traps worked great. And I think they work great because they leaked. Now they're machined with such precision they don't leak, which is why you want to have a hole built into them on purpose so that they leak, you know. So that's why I like having a notch or an orifice built into it. So some of the other things we want to be aware of can cause trouble sometime are sampling methods and devices. You can either sample just in an open way where, say, if you have a buffer prep tank, something that's not considered sterile, you can just have a valve on the side of a tank and open the valve and take your sample. Don't really recommend that, but a lot of people will do that for, say, an upstream process that's not considered sterile. And we are talking about a prep tank. We're going to sterile filter it as you send it down. So it should be avoided for any sterile process. Generally speaking, you want to maintain positive pressure and flow. So you want to make sure that you have a positive pressure to the valve before you open up. You open up, you get flow, you close the valve, and that way you're not really compromising the fluid in the vessel anyway because you have positive flow out of it. And it can be, technique driven that way. So more closed processes, you got the old-fashioned septums and needles. I had some old fermenters that used those. Not recommended these days. You can use various kinds of sample valves, like a Novaseptic or a Sepco radial diaphragm would be my choice for a valve. There are also Keofit valves that go into Ingold ports. And then these would be steam sterilized prior to each use with your attached sample with your sample device attached to it. And then you can either put an autoclave bottle assembly there with a vent filter, and we used to do that in the old days, and I don't know, I think most people are moving away from that, but it's still a technology that can be used. You do have to be careful the sequence of operations that you use when you're opening and closing things like that. You can attach gamma irradiated bags with sterile quick connects to collect your sample in. I think that's a much more popular option. Something I'm looking at right now for one of my is actually using a Nova Septum device. It's a little half-inch flow-through where you can have a single-shot sample bag put onto it, and you can put a new bag on every time every time between uses you can use that.
We actually have on our new bioreactors. It's like, I think it has up to like 12 bags.
So you're probably talking about an NA Connect with a Nova Septum or something?
It's the same thing, but I mean, basically you can take up to 12 samples without sterilizing anything. It fits the triclover on the bottom of the vessel, and it's like you just kind of pop open, and then you crimp it off with there's like a metal band on each sample bag. So then you never have to sterilize, and you don't have to, you sterilize that connection one time and that's it.
Right, well you get,
with the fermenter.
Yeah. And so that would be the bottom one right here.
Yeah,
And there are other brands now. There's at least one other company making kind of like something very similar to a Novoseptum device. Only it's considered disposable, so you're throwing away the entire assembly every time. So yes, and I think if you know exactly how many samples you're going to take and you're never going to need extra, and that style of sampling is probably the best. You don't have to worry about the associated piping. You don't have to do the extra SAPs and things.
Well, a couple new products we got are real aggressive growers, so I mean, you don't really even have time. You have to monitor this thing every hour, and it was like, we had to come up with something different instead of having a Christmas tree of 12 bottles. But,
right.
You know, that's just a mess.
Well, in the days when I was doing microbial fermentations, we did 5 a week in one vessel. I mean, they tend to be very fast, and if you're only in it for a day, yeah, you can totally do that. With cell culture, where you might be in your production reactor for 14 days, you can get to the point where you can't put enough on there. Or if you want to take extra samples for some reason, we're in development, so you know, the development guys often want extra samples. You can run out. One of the nice things about this one is you're still using the Novoseptum device, but you're reloading one bag each time you're doing a sample, so you never have extra bags on there that are going unused. And so it's kind of like in between, the best of both worlds. Something that happened in one instance is one thing you don't want to do if you're using one of those things is ever reuse a needle. Those are designed for single use. And I have known of people who used steel tubing welders to weld on new bags and reuse the needle, and I'm pretty sure our last contamination was due to something like that. Couldn't prove it, but it was the only thing from the timing standpoint and everything that actually made sense. So if you're going to use that, they're great devices. I highly believe in it, but they are single use. Don't reuse them.